Okay, so we want to take a look at the code for a solution to create a circular array. There's not a lot to this one. It's another easy problem to work on, and it goes back to the biggest issue being how do you create and then initialize an array when you're working with generic types. So on a test, uh, maybe some kind of simple class like this, where you just have an array like that. I might have generics. Um, I wouldn't expect more than the methods you see here. And then the biggest issue I think is that however many times we went through the int function type and then explaining that a few times, I realized that that's not something at this level that we're going to absorb very quickly. So I'll try my best to explain it again. We want to pass the constructor for the type that we're working with, but we want to be able to create an array of that type. So what we're really passing is to create a constructor for an array of that type. Okay, once you pass it, it means that this is a function we're going to use that takes one parameter. What is the parameter? It's going to just be a single integer value, because that's what I normally place into the square brackets when I create an array. I want to know how many elements I have in it. So that's the bare bones of it. And then in order to be able to use it, we kind of have to jump through one hoop, and that's to create a temporary array list because it has the method toArray. So this way we can create an array of the size we want. So when we go through the constructor, we want to apply this function. So we're creating an array of that size, and it has the array of that type. So putting it all together, we're initializing and we're asking for the memory to be created for the number of elements that we want in that array. This is one way around that I devised from the complaints that the compiler makes. If you just were to try to cast it like they're saying in the textbook, and you just create a generic array of objects and then you cast it to the type we want. Which you don't want to do it that way. If the compiler is giving you warnings, you should fix it. Okay, and then earlier in the semester, we got into a spot where we really can't get around having to have one compiler warning. So just keep in mind that we've seen this situation where we're working with generics and we've had the update to the Java language where the developers have removed some of the other features where people would try to create an array like this they would try to do it in a simpler way using reflection. So very often I'd go online and I'd see other people trying to create an array of generics. Some would use reflection, some would be trying to do it in more legitimate ways, and then that involves quite a bit more code. So they're trying to check everything properly, but they're not using reflection because that's been removed from Java 17. And I want to be as up-to-date as possible on that, so just keep this in mind. We're working with Java 11, but in the future we would be updating to more recent versions of Java. Okay, so to create an instance of a circular array, we need to have an array of the right size we expect to work with. So if we're going to make this circular, we're going to have the number of elements start at some arbitrary position within the middle of the array and then wrap back around to the beginning. So that's what this, or the crux of this is we have an integer variable head, and that's acting like the beginning position within the array for where we're going to start to insert items. And then when we go to place in some other position when we give an index, it's going to be relative to that head position. So you'll notice down here with the convert method, so this is like our utility function, is doing the calculations for us, so we're not going to have to do this wraparound calculation everywhere else in our code. We just have to program it in one spot and then use it through the convert method. So we take our index and we add it to the relative head position, and then of course we have to use modulo to wrap back around to the beginning of the array in case we go past the end of it. Okay, this way, if the index is less than 0 even, we could even add back on the length of the array, try to fix it, even if we're trying to give something that's negative as an index. We might want to work with it that way. You could implement the convert method in different ways, depending on the functionality you would want out of it. Okay, if you go to rotate, this is how you make it efficient, is because we've got the head variable set up the way it is. Then we do not need to move any of the elements inside the array at all if we want to rotate all of them, because the only thing we're going to shift is the head. So the amount we would want to shift by is relative to the beginning of the array, it's not relative from the head. So we'll take a look at applying this later. I've got some application code as an example. And we apply the convert method to it. So how much do we want to shift from the beginning? And then that's where we're going to consider the head to be relative from that position that we would shift. Okay, and when we go to grab elements from our array, we would give an index, and that would be relative to the head. So we're checking first whether it's within the length of the items that we have for the size of our container. And if it's not, then it's index out of bounds exception. You'll notice that this conflicts with convert, where we might have the negative value passed into the convert method. So you could imagine changing the implementation to maybe cooperate with if you wanted to have negative values. Say, for example, in Python, for those of you that are familiar with using Python, you could use -1 to indicate that you would like to access the end element, the last element in your array. So you could consider trying to implement the same kind of functionality out of your collection. And then, of course, when you go to grab the actual item, you're going to do the convert to shift it based off the relative value of the head position. So because it's circular and we have the functionality to rotate, that together will allow you to have this implementation of the get method. The set method works similarly, but you're passing in your item, and of course you're converting and then setting the value for the item at that rotated and relative position. Okay, there's more to this, but this would be enough to get the basic functionality, all I would expect from what you might write during a test. And you could use the same kind of tricks that I showed you from examples from the midterm, where you could write quite a bit more concisely. So you could squish things a little bit more, and that's okay on a test. When you have to write on paper, don't worry too much about having perfect syntax with perfect indentation style. I do want good syntax, like you should have your semicolons and everything there. But if you miss something, I don't tend to take a mark off, just because you're programming on paper. Okay, if you want the iterator, like they're asking in the question, then I would not expect you to write this on an exam. But I might ask a question, something like, well, what might be the methods you're looking for if you're going to implement an iterator for a container? So that way you could have the enhanced for loop functionality. And I'll show that in a second. Let me bring that up now that I've got it here with I'll shift it over to the right and give you a bit more room. Okay, just to take a look at the main method, I create an instance of a circular array. Notice that I'm passing in the constructor for an integer array and then the number of elements I want in my container. And then the rest of it, I'm just initializing values. So I'm calling the set method for our collection. And I'm passing in 9 minus I because from the relative position, I start at the value 9, and then as the for loop counts up, I'm storing values from 9 and then down to 0 because I'm subtracting I. Okay, and then afterwards, because I could start at the beginning where the head is still 0 by default, then the first element at index 0 would be 9, but then after that I could rotate 3 and I could start my collection at a different location relative. So you'll notice that I placed my elements first and then I rotated, and you'll see how that affects things when we go to print. And print method in my collection is where I implemented the enhanced for loop functionality that shows off why you would want to have an iterator like this that implements iterator from the java.util package. So all you would need would be, we want to keep track of where we currently are for our iterator. We'll start at -1, and then we need the elements. We just need a pointer or a reference. In Java I would call it. If I was programming in C++, you would call it a pointer. And when we create an iterator, we're just going to keep track of where our collection of items are, so our array items. So CircularArray, that's our class that we're creating for this file. It's going to store a different type. So for our for loop in our app client code, we might even want to work with different kind of type and cast it to something else. I might try that after and see whether I can get that to work. But as it is, the code that they're demonstrating when we go to implement our iterator, we point to our items, and then the only methods you would want to override here that they're expecting for your iterator is that it should have hasNext, so that we know when to stop iterating. It's going to return true or false. When you're at the end of your collection, you should return false. So the Boolean expression here, I design it so that it will iterate relative to the beginning of the head and then all the way back to and wrap around the array and then just before the end. So we've got items.length -1, and then the way I do this nicely, this is different from the code that they demonstrate, is just to have convert and take your current position and convert it, because I want to iterate relative from the head. And it'll wrap around okay. And then the next method, you're going to grab the next element. Remember, you're grabbing it from the items array and you're converting it, and they're casting it. And we return. Finally, the remove method, they're just saying if you're going to have this, because the iterator has this functionality, is they're keeping it simple. They're not going to implement it. So I just have a comment inside the unsupported operation exception. And again, the book that I have is actually quite nice because they're using an exception that's actually in the library, unlike the textbook. They tended to want to fabricate their own. So you'll see the unsupported operation exception. You don't have to import because it's part of the package Java lang. You can see it there as well, java.lang.unsupported operation exception. which is nice. Okay, anytime you see an interface as well, the way you figure out the packages there, because they don't list it like they do here with the hierarchy, you just go up to the URL and you can see the package hierarchy. All right, then the print method is mine. I'm just showing how you can make use of the enhanced for loop. I start the value of my index at the head, and then I do the type. So this is not a part of the iterator, right? This is just another method that's available. It's public. I can call it in my client code. So it's extra. And then from the items collection. So remember with enhanced for loop, you always have it with type and then the elements that you're going to work with from your collection. So the array that we have is you put colon and then the name of the array you want to work with. Now that's the code where I wouldn't even have to have iterator implemented. So if I wanted to have something like this in my client code instead, because I might want to do different things other than printing, because arrays already have the enhanced for loop functionality by default, which is nice, but I might want to have something similar inside my client code. So if I want to do it with a circular array, then we should have it implemented with the iterator. And you can see when we go to print, the only thing I'm doing is displaying the index relative from the head, and then the item that corresponds with it. It's going to start at the head when I go through the enhanced for loop. And then we're going to update the iterator, but I have to do that manually. So I'm going to do I+1 and then wrap around to the beginning of the array if I need to. So I wanted to make sure to demonstrate how you could do that even without the iterator. And then when we go to execute this code, you see where it starts from when you print. It starts from the head because I rotated 3 positions forward. And you'll notice that's where it rotated my elements as well. So we've got element 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And of course, we've got the index positions and it wraps back around to 0. And it does a full iteration of the entire array. Okay, I think I would pause and then demonstrate a little bit more with the enhanced for loop in the client code if I can manage that. Okay, I've tried a couple different things. The approach I'm doing to fix the output in order to have the iterator in the client code for the enhanced for loop. So we know the types in our collection are integer, and we've got our collection CA, so our circular array. I'm doing a similar kind of printout from the code inside the class. But then if you take a look at the output, you'll notice that instead of counting from 3 like it does inside the example, and even this printout might not be the functionality you want. It depends on how you would want to use your circular array. Say for example, if you're shifting things, but you still want to consider the index to be the same for whatever reason, because you might have different things accessing it in different ways. And maybe one kind of access, it considers it shifted, and then the other kind of access, it's not shifted. Then you would want to consider different setups like this. So you'll notice that the output for the client code using the enhanced for loop, with a little bit of the adjustments I made in the code, it has the index start at 0, as if we had never shifted any of the elements or rotated them 3 positions. The way to do it would be to have your current value start at minus head minus 1. And then immediately if you do convert, it would end up having items.length minus 1 right away. And you wouldn't even begin your iterations for your enhanced for loop. So in that case, I just check for it and return true to get things started. And then the rest of them, it's fine. And you can keep on iterating until you hit the end of your collection. Now let's say, for example, if you didn't want this kind of behavior and instead you wanted to behave more like the print code that I've got inside the class. Well, then you could just get rid of considering it to be relative. You could start current at minus 1. In this case, I would not have to check. And then you would not be converting your current location. And then when you go to compile, I'll clear that out and then run. I'm expecting now things to be rotated, but the indices, I don't think quite match up, do they? So again, slightly different behavior if you're thinking about the index I from 0 starting from our shift. We've got 0 with element 6, whereas in our print method it has element 0 at 2. So I have different kind of shifts like this. And you'll notice it rotated 3 in the other direction. So 7, 8, 9, it rotated in the other direction for the indices. So keep that in mind if you were going to print out in different ways or try to access a circular array in different ways. It's your choice how you would want to implement this depending on what you're going to use it for. And consider the positions to be relative depending on how you would like to have it rotated or how you would like to consider the shifting. I would never take marks off if the description for the question doesn't even say anything about how it's considering that. So we've got the question description saying, well, you're going to make this class that supports an array-like data structure and it can be efficiently rotated, and that's all they care about in this question. And it has been efficiently rotated. You're doing it in constant time. You only change the position of the head by its value, and you haven't actually moved any of the elements inside of the array itself. And then implementing the iteration for an enhanced for loop like this. You'll notice that I'm not using the generic object element. I'm going by the client code. What's the type that I'm passing in for the generic? And I'm working with that for the enhanced for loop. So keep in mind that they haven't described any kind of specific interpretation of that rotation, and that would depend on how you want to use it. So let's say, for example, if I had a table in a video game and I want the different dinner plates on the table to maybe hold different kinds of food, then you could get more complex in the implementation of this, and you could think about the kinds of objects you would store in the array. Could be different kinds of food. Each one element in the array could be considered a dinner plate. And you could start to get something more along the lines of the previous question that we were looking at with dogs and cats. And then you have a hierarchy where the top of the hierarchy would be food. And then you have different kinds of subclasses for different kinds of food. And then you would implement your polymorphism together with the circular array. Okay, and some people might be standing at a certain position at the table, and then they would access the array at different positions, so you could rotate depending on the different person who's looking at the table. And of course, everything's relative to where they're standing. So that gives you some idea how you might want to interpret something like this and actually go to use it.